The Structure of Existence by Dan Etchegoyen. If you want to know the secrets of the universe, think in terms of energy, frequency, and vibration. And I would add resonance. I am paraphrasing the text for brevity. For greater depth, pause and then read. Early ideas prepare one for later ideas. Please don't jump ahead. The science may have a rough spot or two, but the abstract model itself becomes clear and self-evident. The trees become a forest. The table of contents. Part 1A, Objectivity and Subjectivity in Space and Time. E equals mc squared can be rewritten as energy is to mass, as space squared is to time squared. The four elements of reality, each separated from the others. Space and time are the axes of the field continuum for the objects of the mass-energy dichotomy to exist in. Existence is mass-energy motion in space-time. Motion through space and time are both quantized. 1 Planck space per 1 Planck time is the speed of exchange bosons of information. Fermions must be slower, including zero relative speed. Tachyons must be faster, including infinite relative speed. In the field of action, the three axes of space are mutually perpendicular. Three mutually perpendicular plane pairs make a cube. The diagonals on a cube make a dual tetrahedron. The three axes of time are mutually parallel, past, present, and future. Mass-energy objects resonate as standing waves in the present, reflect on the past, and project into the future. To be is to resonate in the constantly changing present with all other things. That resonance projects into the future, space, and time, and reflects into the past. Geometric structures have internal resonances, displayed by passing planes through solids or lines through planes. Motion is through time and space together, so on the diagonal. Plane passage through diagonals on a cube is through tetrahedrons. Resonant symmetries of the tetrahedron's plane passage are square and triangular. Energy exchanges are quantized. Changes in resonance states is music. Being is harmonious participation in the resonant exchange. Resonant waves exist on surfaces of opposing tensions and can be straight or curved, parallel or perpendicular, in phase or out of phase. These standing waves divide finite lines, either straight or curved, into a quantized number of divisions. Plane passage through increasingly faceted objects describes a path that is increasingly more curved than angled. Plane passage through a cone shows curves associated with orbital dynamics. The closed elliptical, flat parabolic, and open hyperbolic curves on a cone yield the sphere, cylinder, and torus as extended objects. A flat, straight path on the surface of a cone yields curves that are similar to a sectioning plane, but the type of curve is dependent on the cone's height to base ratio, not the angle of the sectioning plane relative to the edge of that cone. All things exist as resonating standing waves, with node points that are fixed points that evenly divide the enclosed finite space. One standing wave resonates with another standing wave via their common node points. Simpler ratios resonate more strongly than complex ratios, but all fractions resonate. Standing waves appear to move in two opposing directions at the same time. This bistable image of resonant interaction shows the interference of a dual reality like the objective and the subjective. The two flows interfere both as constructive at 90 degrees and as destructive at 180 degrees to each other in phase or angle. The unity is described as indescribable, a self-contradictory entity. But nothing is directly describable. Only attributes of any entity can be described. Attributes invoke separations. The number of separations or divisions of the whole speaks to the kind of divisions of the whole. Divided attributes of an entity only tangentially describe that entity. Any entity can be divided by any number. When you divide the universe into 4 parts, one reality you get is mass, energy, space, and time. Each and every division of the whole is itself a whole with its own divisions, a fractal structure. Each number of divisions of the whole has its own abstract table of correspondence. Duality. Objectivity and subjectivity compete and cooperate as complementary aspects of a single event of being, both together and neither alone, like space and time, parallel and perpendicular. Objectively, all things are different from each other. Subjectively, all things are similar to each other. Objective, deductive reason looks for differences in the similar, and subjective, inductive reason looks for similarities in the different. This is subjective abstraction as compared to objective concreteness. All things are endlessly divisible, and divisions can be compared by number. By all numbers, all things are endlessly similar to and endlessly different from all other things. Comparisons must be of similar attributes common to the compared things, like mass, complexity, resonant state. No two things are intrinsically more similar to each other nor different from each other. All entities exist by resonating in the objective concrete and the subjective abstract. Each depends on the other. Exchanges supporting both resonances are of mass, energy, and the information of space through time. Standing wave resonances may reflect on the past and project into the future. Objectively, all things share the same universe of reality. Subjectively, all things exist in their own unique universe or reality. Objective reality is what is measurable, quantities. Subjective reality is what is not measurable, qualities, like depth of eye contact. Every entity has a self and a not-self. There is resonant flows in each realm and between each realm. Thus, this chart. Part 1b, Godel, Incompleteness, and Reality. Godel proved no set of axioms can be consistent, complete, and finite. A finite, consistent set must be incomplete. It therefore follows that a finite, complete set must be inconsistent, or self-contradictory. A consistent, complete, and infinite set of statements has endlessly expanding levels of contrasting statements. Finiteness, consistency, and completeness can be represented by the truth, falseness, or undecidability of all the statements in that set. For finite sets, completeness or not, and consistency or not, form a grid of possibilities. Consistent and complete is not allowed. Inconsistent and incomplete may be informationally less helpful. Consistent, so incomplete, is what Gödel proved. A consistent set will contain unprovable statements. Complete, contradictory sets make up many things: direct oppositions of duality, harmonious fractions for higher numbers. For completeness, one must look for self-contradiction. The abstract structure and process of existence. Part 2. An extension of one dimension into new space-time is around, across, and along. Varying these three quantities makes a wide range of objects. A surface of any two directions of extension is perpendicular to the third direction. An extension of dimension may be straight or curved. Curved makes a circle and is local, like mass. Straight line ends meet at opposing infinities and is global, like energy. Wave-particle entities propagate into new space-time to continue resonating in the ever-changing present. The isolated components of mass, energy, space, and time have specific rates of exchange. Curved and straight lines can both have standing waves with node points that project and reflect. A smaller half-radius circle is embedded in various divisions of the full-sized circle. Reflection within a pi wedge duplicates the projected path through the circle. Projection to rational corner reflection points are duplicated as reflection within a single square. A cone rolls out as a pi wedge. An infinite path flat on the cone surface has a finite number of turns around the cone. The path of a standing wave is both straight and curved. The two paths are at 90 degrees to each other. How one path is measured affects how the other path is perceived. Resonances occur between the extremes of infinite and zero, which can be indistinguishable. All standing waves resonate. All points on the curved path from A to B have A and B at 90 degrees to each other, cooperative perpendicular. All points on the straight path have A and B at 180 degrees from each other as competitive opposition. Reflections around inside a circle at all chords will have their own common tangent inner circle. Sectioning a cone or cylinder can yield the ellipse. Lines reflecting around inside an ellipse will all be either around, along, or across the line between the two foci on the ellipse. The unit line reflects around inside larger circles. Specific sizes resonate exact numbers around. For any size circle and the inner tangent circle to it, the area remains constant as long as the chord slant tangent length between the circles also stays constant. Consecutive extensions into space, both straight and curved, resonate at node points that can project or reflect. Consecutive straight and curved extensions into space are, in a sense, the same as a single straight and curved extension into space, and yet the number of divisions of the whole speaks to the kind of divisions of the whole. The unity is described as indescribable, a finite, complete, but inconsistent description. Duality is ubiquitous. Trinity shows the actions that connect both parts of duality. Of course, there are two trinities, one objective and one subjective. Those two triangles make one tetrahedron. Escher showed how circular routes can be constantly uphill or constantly downhill. Downhill is entropy, disorganization. Uphill is syntropy, organization. Objective entropy and subjective syntropy resonate together on the diagonal, allowing both to function. Mass, energy, and information can all be either objective or subjective in a duality, depending upon position, like in rock, paper, and scissors. Buckminster-Fuller shows how two triangles with overlapping vertices can fit perpendicular to each other, each within the overlap of the other. This makes one objective and one subjective unit of information. All extended points in spacetime are node points of projection, reflection, and resonance. Node points are of angular change. When two circles overlap, if one crossing is at 90 degrees, so is the other, regardless of their relative sizes. Node reflections and node projections can be indistinguishable from each other. The vertices of a triangle are common nodes of projection and reflection. The objective and subjective trinities are triangles of actions. The three objective actions are be, do, and have, the three kinds of verbs. The three subjective actions are feel, know, and interact or resonate. Without specific endorsement, I should point out that in Western Judeo-Christian religions, heaven and earth correspond to subjective and objective reality. Father, Son, and Holy Spirit correspond to the three subjective actions of existence. Father is the feeling of love, Son is the knowing of the world as man, and the Holy Spirit is the interaction between man and God. Objective reality and subjective reality are each a part of the other. Both exist together, neither exists alone. Abstractly, all things, including consciousness, exist according to the same set of rules. Objective and subjective realities resonate in each other, in the present. Patterns projected to persist in the future support continued existence. Reflected past reality informs the present with resonant echoes of similar actions. Objective being and having oppose each other. Subjective feeling and interaction oppose each other. Objective doing and subjective knowing oppose each other. Doing and knowing both mean change. The dual tetrahedron is the only polyhedron set that is its own dual. It is supersymmetrical. No matter how you orient the two tetrahedrons relative to each other, all six pairs of edge lines that cross will always touch. It has a square symmetry and it has a triangular symmetry depending upon perspective. Centers can move apart 4 different directions, 2 different ways each, and the corners can move together 3 different ways times 2 each is a total of 6. So it's 8 open states and 6 closed states. The 3 objective actions of existence resonate indirectly with the 3 subjective actions of existence. Where dual tetrahedrons' edge lines touch and cross, there is a mutual node point for both tetrahedrons. The common node point for the crossing edge lines divides each line by changing fractions as the orientation between the tetrahedrons change. Exchanges between edgeline waves on the 2 tetrahedrons creates common opposing motions between them. The circular motion at the vertices creates inertia and tension for the waves to resonate on. Change the orientation between the tetrahedra changes their resonant state of existence. changing resonances becomes harmonious progressions. Simpler resonance supports higher resonances. Higher resonances guide simpler resonances. Delayed or deferred gains of resonance on one level of vibration may impose gains on another level. Gain and loss become relative. Objectivity and subjectivity both cooperate and compete for gain. The local geometry of the space-time field. The more straight and curved extensions of space-time are in contact with other extensions, the more complex and higher dimensional the resonations can be. The mass of several small circles, or spheres, is gravitationally closer to another circle than one big circle. The force of attraction between circles drives dividing the mass to reduce the distance between centers. The opposing force is to shorten the distance around a center. This happens when two circles' areas combine into one larger circle, like two soap bubbles combining into one. The force to shorten the distance between circles' centers and the force to shorten the distance around circle centers oppose each other. Within a circle, other circles' force toward the edge is centrifugal. The same opposition of forces between and around are around instead of between. The unit circle is the base limit for extensions into space, both internal and external. Two circles can overlap. There are various stages of overlap corresponding to Venn diagrams for logical states of being. There are no straight lines, only infinitely large radius circles that resonate inside and outside of smaller circles. Straighter inside means larger outside. If the tangent line between any two concentric circles is constant, then so is the area between those circles. This is Mamikon's theorem. When the inner circle approaches zero, the tangent resembles a diameter. The expanding circle pair will reflect exact numbers around at specific relative sizes. Any two reinforced resonator circles will have equal areas and a rational ratio of circle divisions to resonate with. Various reflective resonances within a circle each has its own projective resonance outside the circle, which is inside another circle. The field of interaction can be either finite or infinite, and either bounded or unbounded. Consecutive extensions make a line. Consecutive lines of extensions make a surface. Adjacent lines of extensions can be in step or out of step with each other. These two tessellations have different resonant flows, ways for circles to contact its neighbors. Perpendicular extensions have flows along two axes. Staggered or triangular extensions have flows around three axes. Plane passage through a tetrahedron shows both tessellations from different perspectives. A tetrahedron is the smallest such closest packing arrangement in 3 dimensions. It has 2 spheres on each of 6 edges. This smallest tetrahedron has no center sphere. The smallest amount of closest packing with spheres that has a central sphere forms a tetrahedron with 5 spheres on a side. Just the spheres that touch a central sphere together form the vector matrix. Stacking similar 2-dimensional surfaces into 3 dimensions yields varying crystal structures. Offset stacking into gaps gives the square-based pyramid and the triangular-based tetrahedron. Both these stackings are the closest packing of spheres seen from different perspectives. Square stacking perspective has 1 gap per extension. Triangular stacking perspective has 2 gaps per extension, and has stacking options unavailable in square stacking. In square space and triangular space, primes in the numbers laid out there have the same patterns, but different slopes. Compass magnets arranged in a square tessellation wind up all pointing in the same direction, one of the four possible. Compass magnets arranged in a triangular tessellation wind up aligned to one of three axes, but pointing in alternating directions. The field can also be tessellated with hexagons, but direct flow through the extensions of a hexagon does not happen. Without the central extension, there is no direct flow, and flows across a hexagonally tiled surface are of a higher group order. Where geometry is local, topology is global, and vice versa. Topology on one scale is geometry on another scale. Global topology of the space-time field. Gravity, black holes, dark energy, expansion of the universe. Our universe is a local density fluctuation, a wave pulse. All things interfere or resonate with all other things. Interference waves resonate with other interferences, creating ever more complex resonances, and the world. At the bottom of all this resonance are the three fundamental waveforms that exist before any interference. Waves have a source and a wave speed. When the source moves slower than the wave speed, the shape is a circle or a sphere. When the source is faster than the wave speed, the shape is a V-wake or sonic boom cone. When the source and wave speed are the same, the shape is that of a propagating torus. Waves that are faster or slower than their sources can be continuous and will expand to cross all observers. The torus, with matching source and wave speed, are quantized units of exchange, going from point to point. Resonant paths on the surface of a torus are at rational slopes. Our wave pulse universe is a place of constant change, an oxymoron, self-contradiction. Waves on this surface must keep moving to hold still. Each type of wave creates its own kind of universe, its own unfoldment of space through time. Consider the propagating torus as a two-dimensional universe, one dimension of space and one of time. Our universe is more complex with more dimensions, but the topology and dynamics of Einstein's equations on a simple torus are easier to visualize. Motion through space is in either of two directions, but motion through time is in only one direction, at least in the classical sense. Gravity is indistinguishable from acceleration. There is linear acceleration and angular acceleration. All the points on the surface of a propagating torus move in a circle and experience angular acceleration, deforming the surface of the torus. Accelerated deformations are of mass and energy and create a gravity well, depressions in the propagating torus. Eventually, the depression in the torus gathers enough mass and energy to collapse the field. A new, smaller torus is emitted, with the axes of space and time reversed. This is a black hole. In the black hole, motion through time is in two directions, but motion through space is in only one direction. Time and space switch alignment of linear and lateral. The propagation of the torus causes its increasing global expansion and will cause its eventual contraction as well. This is its global inertia, its dark energy. Locally, inertia causes field collapse in black holes. Forces, self-similar structures, and resonant divisions of the whole. Melinda Green's depiction of the periodic table as a fractal shows that there are different levels of description for the same information. Interference patterns are made from two patterns together and neither alone. Similar patterns interfering can make an interference pattern that looks similar to the patterns that is composed of, but on a different scale. When both patterns are in the same plane, the interference pattern is in a fixed relative position to the two patterns. But if the two patterns lie on different planes, then the interference pattern may become fixed relative to the observer and no longer the component patterns. Driving through an orchard, the trees pass by, but the lanes between the trees hold their positions. The appearance of interference patterns changes when the contributing patterns change. There are three kinds of change between patterns relative to the observer: across, along, and around. Higher energy muons, taus, strange top, charm, and bottom quarks have shorter wavelengths. Tetrahedrons orient themselves relative to nodes between waves. Higher energy means shorter wavelengths and smaller change in orientation between tetrahedrons, catalyzing the full change of the electron, the up or down particle. The color force reflected inside the baryon also projects outside the baryon as the strange force of the mesons. This arrangement of particles and waves, sequenced as their forces cool out and separate. There are corresponding bosons and fermions for each force as its symmetry is broken. As expansion and cooling causes the forces to each break symmetry in turn, even the electromagnetic force can cool to the electric force and the magnetic force. Among all forces, the Higgs field is the same everywhere, and the weak force mediates intermittent changes and then disappears. The weak force does not participate in resonant interaction to persist. This leaves four forces to match the four elements of existence. When dividing the universe into four parts, there are six connections between those parts. This is the tetrahedron of existence, the objective dichotomy, and the subjective continuum of being. Dividing the circle by 5 and using the square root of 5 show the ratio of phi, but so do many other geometric constructions. Dividing the unity by 6 shows 3 axes of space and 3 axes of time for resonances to reflect and project. Stressed nodes of the past will echo similar structures back to the present. Dividing the unity by 7 shows how divisions have a circular nature in the progression to the next octave of resonance. All things resonate. Coloring each number in different bases shows the patterns of hierarchy with placeholding. The same self-similar structures occur on all levels. The abstract structure of existence can be seen as a regular fractal with 8 parts as one. Objective doing and subjective knowing form a constant perimeter at any ratio of the two in the tetrahedron. Many definitive arrays with 8 parts can align with the 8-part fractal structure of existence. Forces fall off, constants, trigonometry, and the Trammel. 180-degree rotation on any three-dimensional object along any axis is identical to 180-degree rotation around the other two axes together. This is the same as in CPT symmetry. A spinning object will resist acceleration directly against it by moving its spinning center of gravity away from the source of the direct acceleration. The 90-degree angle to A and B on the circle's arc points can be seen as the x-y axes with the circle diameter as the hypotenuse. A squared plus b squared equals c squared does not have to be squares. Any similar shapes work just the same. Square numbers can be found in the triangular symmetry of space, in the gaps. Similar semicircles for sides A and B each have tangents with the semicircle for the hypotenuse that are the same length as the other side. There is an inverse relationship between the two sides of a Pythagorean triangle. In any model, whatever changes are observed depend upon whatever is held still. The rectangles bounded by the circle have a constant hypotenuse, diameter, and radius. The curved line is a second-order linear function, x squared plus y squared equals h squared. The rectangles within the diamond have a constant length perimeter and are all a first-order linear equation, x plus y equals d. These points are on a straight line. Resonances occur in both straight and curved space together. Points on both spaces coincide only when either x or y equals 0. Reflections and projections occur in both flat space and curved space. The constant perimeter rectangle set of a first-order equation is found by passing a plane through a tetrahedron from the square perspective. Passing a plane through a tetrahedron from the triangular perspective yields a constant ratio of facet area to object volume. There is no center to a circle. There is always a tangent line and an inner circle that can approach 0, where tangent and diameter approach unison. As long as the tangent length remains constant, so does the area between the inner and outer circles, which get closer together as the circle pair expand. The tangent line can reflect around within the circle pair. At specific sizes, the tangent reflects around an exact number of times, and there is reinforcement for harmonics of all sizes to resonate, exact fractions, and identical areas for interaction. The barely curved, globally straight tangent line reflects back and forth around the inner circle that is as small as the globally tangent circle is large. Each new unit tangent to an inner circle makes an outer circle with one additional unit of area and a narrower arc that divides the circle into one more radial division than the tangent before it. Again, in any model, the part that is held still determines how the moving parts change. Any description of reality must be indirect and will always miss the mark. And this explanation on the tangential nature of reality itself completely misses the point. There is a gradation from local to global. A local line is more curved, a global line is more straight. Where two local lines are concentric, two global lines are parallel. The center of a circle is not a point. It is a smallest circle, a single extension, both straight and curved, of space-time. A finite, smallest unit avoids the mathematical challenges of point-like infinities. The black hole singularity is where straight and curved switch places. Contradictory ideas on one level can be in harmonious agreement from a higher perspective. All there is the universe experiencing itself. Force-strength between things is akin to the size of the reflection of the self as seen in all other things. The reflected image and its visual falloff is modified by the number of dimensions involved and by the curvature of the reflectors involved. A full-sized circle with a half-sized circle diameter circle in rolling contact with it, trace out the nephroid on the outside and a straight line on the inside. Each point on the smaller rolling circle traces out its own line, curved or straight, onto the larger circle. The equations for the trigonometric circle and Pythagoras' hypotenuse are identical. Trigonometry has its radius, and the hypotenuse has a trammel. They move together around a center, but rotate in opposite directions. Both lines meet at the 4x and y directions, but the one point that they both have in common is halfway along them both and exists in a circle around the center, not at a point. Trigonometry is well examined. The trammel is different. On the smaller inner rolling circle, any opposing points will trace out crossing lines at 90 degrees. The center between them traces out a circle minimum. The path around the center changes with the length of the trammel arm. At zero distance, the path is a circle. This path changes from circular to elliptical and then to a straight line path at the distance to the edge of the smaller circle. For trammel path distances greater than the smaller circle, the path begins rounding out again, towards circular at infinity, but going the other way around than the center point on the yellow circle. The abstract topology of the four solids. The basic relationship between square areas and circular areas and volumes. The relationships between curved and flat surfaces and their areas. Bound in a 1 by 1 by 1 space, if the volume of a cone is 1, then the volume of a sphere is 2, and the volume of the cylinder is 3. The bound space, sphere, and cylinder have the same surface area per volume. Shorter cylinders, and presumably spheroids, would have a higher ratio surface area per volume, and taller cylinders and spheroids would have a lower ratio of surface area per volume. Any height of cones with the radius of some cylinder and a stack of spheroids with that same height and radius will add up to the volume of that cylinder. A volumetric relationship between square and circular spaces and volumes. All variations of cones with equal heights and radii have the same volume and are interchangeable as needed. The sphere, cone, and torus all share a dynamic wave relationship. The sphere, cone, and cylinder all share a static volume relationship. The cylinder and the torus share the same square to circular relationship that the cylinder shares with the cube. The cylinder and torus even have the same volume per length when measured from their center lines along each object. The sphere, cone, and torus and cylinder are all deeply interconnected. An analysis of that connection is what follows. The sphere and the cone are the same, except for the speed of the source relative to the speed of the wave. A slow source makes a sphere, a fast source makes a cone. Matching wave speed and source speed makes the torus. The sphere and the torus are the same, except for an offset on the axis of rotation on the torus. Two concentric circles have a tangent between them that rotationally sweeps out a fixed area, dependent only on the length of that tangent. Moving that pair of circles through the z-axis creates a constant volume of tube and a squared surface area sweeping out space, tangent to the inner cylinder. As long as the z-axis height equals the tangent length, then the tangent plane to the inner cylinder will always intersect the outer cylinder in a perfect square, no matter the size of the circle pair. A sphere, minus a cylindrical hole drilled through it, sometimes called a napkin ring, also has a constant volume, dependent only on the length of the cylindrical hole in the sphere's slant napkin ring, not in the changeable sphere's radius. No matter the radius, a plane tangent to the inner cylinder intersects the sphere in a perfect circle of fixed radius that sweeps out a constant volume for that cylinder height. The tangent between two circles generates a constant swept area between those circles. If you tilt the axis of rotation into the paper, then the circles rotate into spheres with a constant volume for the same height between the nested napkin rings. The cylinder and the cone are the same, except the straight vertical lines of the cylinder become tilted across the apex, rotated 180 degrees around from top to bottom. In a 1 by 1 by 1 space, all those straight lines go from parallel to perpendicular with each other, with a full half twist from top to bottom. The parallel and crossing straight lines of the cylinder and cone are both tangent to the inner cylinder, whose size relative to the outer cylinder size determines the amount of twist top to bottom of the cone slant cylinder intermediary. The cone, sphere, and cylinder are flat shapes swept around an inner cylinder. They are the diamond, the circle, and the square. These shapes are variants of math's LP space for pi. With the diamond and square, pi equals 4. For the circle, pi equals 3.14159. Where the cone, cylinder, and sphere are swept as tangents around an inner cylinder, the torus, being offset from the central axis, becomes perpendicular to the around axis instead of tangent to it. A new dynamic. Reducing out common symmetries yields only the most abstract objects for comparison. These four representations can all be spun on either axis and sweep out the same volumes. These representations, grouped in one quadrant, display an additional symmetry on the diagonal. From a 45-degree change in perspective, the outer square of the cylinder becomes the inner diagonal of the cone. A circle remains between the two in this new configuration. Repeating the 45-degree change returned to the other perspective again. The two perspectives just alternate in concentric exposition. An inner cylinder can become an outer cylinder and vice versa. A detailed chart of the shadow areas and swept volumes of the four solids and divisions within them. A summation of those areas and volumes. The four solids, now better understood, have characteristics in common that can be compared to each other. There are two ways to divide the four solids for comparisons. First, you can divide one element from the other three. There are four ways to do that, showing four characteristics of the whole. The other way to divide the four solids into groups is to divide two of the elements from the other two. There are three ways to do that, making sets of pairings that can be compared for similarities and contrasted for differences. For watching this whole thing, I imagine the features that these objects present upon examination have some analog familiar to the physicists and mathematicians with skills I could not achieve. The connections I have shown seem meaningful to me, even if I don't always know what that meaning is. Please share with me what has resonated with you and how. You can use the Structure of Existence forum on Facebook. Oh, and please like and share if you would. Thank you so much.